And you find the higher powered roots mixed in with all kinds of other problems. So you're going to see some variables and you're going to see some numbers. But y'all seem to be struggling with the numbers the most. So let's talk about the numbers. So if I have an index of 5 and I'm trying to find the fifth root of 160, the fifth root of 160, then what I have to do is go to my fifths. So I have my index card, and on my index card, I wrote out the fifths. So I know 1 to the fifth means 1 times 1 times 1 times 1. That's 1. So 1 to the fifth is 1. 2 to the fifth means 2 times 2 times 2 times 2 times 2. That is 32. 3 to the fifth means 3 times 3, that's 9, times 3 times 3, that's another 9. So 9 times 9, that's 81, times 3. So 3 to the fifth is 243. So you need to have those in your index card, on your index card, in your brain, something, okay, your fifths. When you see that index right there, you start thinking fifths, all right? Okay, so let's take a reverse of that real quick because I want to make sure everybody completely understands this. So what that says to me is that if I take the fifth root of 1, I get 1. If I take the fifth root of 32, I get 2. Because it took 2 times 2 times 2 times 2 times 2 to make 32. If I take the fifth root of 243, I'm asking you what 5 things multiplied together to get 243. They have to be the same, and it is 3, because 3 times 3 times 3 times 3 times 3 is 243. So that's the relationship between your exponents and your roots. All right, everybody okay with that? Okay, so now the way that the program explained to you is they wanted you to break these down into primes, and so they had you do the prime factorization, right? So you started working that 160 down. To me, it's easier to start with the roots. So what I do is I come over here and I take this 160 and I start trying to divide it by these perfect fifths. Well, I know that 243 won't go into 160, so I'm going to try 32. So on my calculator, I'll take out my calculator, and all you need is these right here. I don't know the answer. I mean, I'm going to be working on it just like you are. So I'm going to take 160 divided by 32, and I sure hope it works. It does. Okay? 160 divided by 32 is equal to 5. So, like when you were in elementary school a long time ago, your teacher taught you, hopefully, the families. Y'all know the families, like 6 divided by 2 is 3, because 3 times 2 is 6, those families. Okay, so if 160 divided by 32 is equal to 5, then 5 times 32 is equal to 160. That's why we break this down. So we break it down as the fifth root of 32 times the fifth root of 5, and we can come back over here and look. We know that the fifth root of 32 is 2, so this is 2. It simplifies as 2, and there's no fifth root of 5. You notice there's no 5 on there on my perfect fifths, right? So the answer would be 2 times the fifth root of 5. So the fifth root of 160 simplifies 2 times the fifth root of 5. Okay? So y'all be careful with those. The other thing that I noticed, I wanted to point out one more thing. The difference between even roots when your index is an even number, or odd roots when your index is an odd number. So you guys are getting to those. I noticed it in your homework set. it's in the equations, and that's what Giovanna is working on right now, okay? So if I'm going to take the square root of negative 25, I'm going to say that that's not a real number, okay? It's not real. Now, if I'm in the complex section, I could simplify that because you guys have started talking about complex numbers, and the negative under a square root makes an I, and so the square root of 25 is 5. So I could say that this is 5i, or I could say that it's not a real number. Okay, when you start looking at the roots, the index, and when it's odd, when you're taking an odd root, like if I ask you to take the cubed root of negative 8, that negative right here, if the index is odd, is fine. Because a negative times a negative times a negative makes a negative. Over here, a negative times a negative, if I said, oh, that would be negative 5. It's not true, because a negative times a negative makes a positive. Doesn't work right here. That's why we call that the imaginary unit, 5i. But over here, it's possible. I can take the cube root of a negative number, and I just happen to get a negative number. So the cube root of negative 8 is negative 2. So y'all be careful with those, okay? Does anybody have any questions? Anything else you want to ask for today? Okay, well, let's get busy